We are going to understand limits and derivatives. In details, we will be solving this in details. Let me do something. Here, are you ready? Yeah, name of the chapter is limits and derivatives. We have two things, limits and derivatives. We are starting with the limits. After completing limits, then we will take derivatives. In limits topic, we are all these topics. Need of limits, we will see what is the need of limits. Then we will see graphical view of limits. Through graphical, we will try to understand about the limits. Then limits of a function. As we know that function is a separate lecture, we have studied this function, and here we can see connection of a function with this. That's why it is said that there are a lot of chapters in mathematics that are connected to each other. Here you can see this happened here, function is coming over here. Limits of a function. Then we will say mathematically definition of limit. Mathematically definition of limit. Okay, let's start. Here we have a need of limits. What is the need of limits? Your mind should be empty with peace. Okay, that's it. Need of limits. Here we are saying function of x is this much, 3x upon x. What are we saying? We are saying that when we will put x as an input, then we will get this as a y, and as we know that y is the output. Are we clear? Yes, we know that. So next, find the value of a function at x is 1. Here it is saying that x value of x is 1. This is input. 1 is input. Now what are you going to do? You will substitute this value in x. Here when you will put this in this, then you will get a value of y, isn't it? This is very basic, and all these are taught in function chapter, but I am repeating it here. I am saying that this x will be input and y will come as a output. Here it is saying that when you will put x as an input, then you will get this as a output. So 1, 3 upon 1, 3. We are getting 3. 3 is our output, and it is the value of a y. Okay. Now here we are going to put how much? X is equal to minus 2. In that case, 3 to just 6, minus 6, then 2 upon, okay, minus 6 upon minus 2. Of course, we are getting, hold on, 3 again, 3 again, 3 again. Here 3, and when we will put 3, then 3 3 is a 9, and then here again 3. So inputs are different, but outputs are same. It is valid, but inputs cannot be same. If this is happening, then if inputs are same, then it is invalid. Yeah, outputs can be same. As you can see, this is example. Here we are entering these different inputs, but output are coming different. No, same. Yes, same. Again, same. It is a valid. This is valid. It works. And what does not work, I have told you. Now we know that this will give us 3. Okay. Now x is equal to 0. Then in that case, what will happen? X is equal to 0. When we will put here 0, then this will become 0. It is not defined. This is not defined. Why? Because denominator should not be 0. Denominator should not be 0. Functions say that the denominator should not be 0. It should be greater than 1. It should be greater than 0. Here, domain are 0. Okay, this is domain. So domain should be what? Greater than 0. Should be real number, but except 0. Meaning of this is what? Domain should be real, but except 0. It is the meaning of this. Now next. Here any number you can put, but except 0. Graphical view of limits. Hold on. Let's see what are number of slides. So we have 149. Okay, no problem. We will see. Yeah. Graphical view of limits. So here we have this much. It is we know that this denominator should not be equal to 0. Even domain should not be equal to 0. Okay, whether it is a numerator or in a denominator, domain should not be equal to 0. It should be real but except 0. Real number except 0. As you can see here. When we take x as a 0, then what happens? We get a linear parallel, a line which is a parallel to x-axis. It is not defined. This is a constant function. It is known as constant function. 3. Why is a 3? A left neighborhood of 0. Here we are entering x as a 0. X as a 0. This is 3. Function came 3. If right neighborhood of a 0, this. Okay. Next, limit of a function. We know that this is a constant function. What is okay? Limit of a function. Limit. Value of a function versus limit of a function. Here we have a graph. Okay. This is a curve. It is what? Y is equal to fx, or you can say fx is equal to y. F is what? Function here. Over here, f is a function here. Now, here we are saying that this is x, then it will be y. That is what we are saying. That is what we are saying. Value of a function at x. It is what? X is a, so y is coming as a l. So this would be output. When x is a, then output will be l. Okay. So this was value of a function. Okay. When we put value of x, then we get output. This is what is the value of a function. But what about limit of a function? What about limit of a function? That's it. So here x is equal to a, and then here we are saying limit. This is the limit of a function. This is what is the limit of a function. Here we are saying x tends to a. X relates to a. That is what we are saying. X tends to a. Which means, meaning of this, we will say, don't worry. Meaning of this is what? From 0 to a. From 0 to a. These values, from 0 to a, these values will be limit. And these values will be applied in this x. In this x. then you will get this. But when this value, then you will get this. Okay. Here we are getting L in both cases. Now over here is what this okay, it is what a comma L. This is fa, yeah, not defined. It is not defined. Why? And this is a defined. It is L, and this is here we are saying it is what this fa is a m, and x is still a, and in that case here it is equal to L. Left hand limit and right hand limit. Limit of a function at ax is equal to 8. Okay, here this is left. Limit x tends to a, okay. So this is what L, we are getting this much, this number. Okay, left hand limit is equal to right hand limit. Whatever value will be here, so will be equal to here. So h is very small. Where is h? This a minus h. A minus h is very small. Okay, so f function of this would be a minus h. It is talking about this. In that case, we have this. We use the limit for very small. So h tends to 0. Yeah, we know. Here we have I'm going to ignore this. Later we will discuss it. Let's see. Complex number. It was not working. Will it still not work? No problem. Gravitation. Yeah, gravitation. We selected this chapter of ninth standard. We will explore it. So, in this, we will see what is the gravitational force, then what is the centripetal force, then what is the universal law of gravitation. In details, we will be exploring. We have this much slides. Let's begin. Okay, gravitational force. Okay. What is the gravitational force? Okay. This picture is showing about a gravitational force. A apple is falling, and then suddenly, this Newton sir realized that how did it fall. Then he started doing experiment. By experiment, he found a lot of things, and those a lot of things we are going to see in this. Here, what is happening here over here? He is pulling this. He is pulling this. This is what is happening. He is pulling this. It means he is applying some newtons to pull this. This is what? It is a force. Pulling or pushing is a force. Just it is a definition of a force. Here, yes, this is a force. But this would be this contact of this tires with this earth is what it here is happening something. Is that friction? Friction is also force, but it is just opposite. It blocks the object. Here, this motion. What is happening here? Yes, it is moving. When force is being applied, then it is moving. Of course, it moves. It is moving. What do I want to say? I want to say that without force, anything will not move. Anything will not move. Something moved, it means force was applied. Here, this picture is telling you that I am throwing something, a ball. You can say I am throwing a ball. This is also a force. This is also a force. But this force will be something else. In this case, he is not pulling or pushing. It is applying upward force, you can say. This is applying upward force. Okay. Now look at over here. What is happening in this? All the planets are rotating around the sun. But sun is not rotating. Sun is at center, and all the planets are continue to move, and these are also motion. But which kind of motion? This is circular motion. This is circular motion. Here objects are moving, planets are moving. But can we say that force was applied on this? No, it is invisible. There is also force, which is forcing this planets to move. But we cannot realize, we cannot observe directly. This is invisible force. There are some invisible force, for example, gravitation, magnetic force, this type of. Here we will see that this is a gravitational force. Look at here. This moon is rotating around the earth. It is moving. But what about force? Where is the force? Nothing is forcing this moon. nothing is applying force on this ball, then how is it able to move? Yeah, answer would be what? Invisible force is applying force on this. There are some visual force and invisible force. Here, in this figure, we can observe directly is that motion. But in this figure, only in these two figures we cannot observe a force directly. But in this figure, we can observe a force directly, which is upward force. Okay. So from this, you are clear that there are some visual force and invisible force. Now, in these three figures, you are crystal clear that yes, objects are moving. You are crystal clear. We can see directly. This is visual. Now next. Name of this guy is Isaac Newton. He discovered Newton's law. He discovered gravitational law. He discovered a lot of things. Name of this person is Isaac Newton, and he discovered also gravitational force. As I told you that this is a person who did a lot of experiment, and some experiment we are going to explore, which are by this Isaac Newton's law. Now in this case, there is a two objects. First is the apple, second is the earth. First is apple, second is the earth. What can we observe from this slide? Earth is attracting apple and apple is attracting to earth. This is what is happening. But again, I want to say that this is invisible. We cannot say directly that objects are attracted to each other. Remember, gravitational force is a attraction force. It is not a repulsion force. In the discussion of this gravitational force attracts only, not repulse. Here we have an example. In this example, this earth is attracting this and this apple is attracting this. But remember, both will be attracting with the same Newton, with the same force. For example, this apple is attracting this with 60 Newton, let's say, and this earth will be attracting this with 60 same Newton. Earth attracts apple. So this discussion that we understood about this is the gravitational force. Here both are attracting to each other. It means this is what gravitational force. And you know that this gravitational force, magnetic force, all these are invisible. All these are invisible. Only we can feel, but not can see. Does apple also attracts earth? Answer is yes. Here what is happening? It goes, then it comes at same position, then again. At a certain time, it comes, then at a certain time, it goes. Then it is continued. This is what is happening. Here our question was, here every action has an equal and opposite reaction. This is Newton's third law. As you know, this is Newton's third law. Every action has an equal and opposite reaction. Here, this gun did action, and this side is what? A reaction. This side is what? Reaction, as you can see. Force on a ball and force on a cannon. This is action and this is reaction. Same here, when this ball will apply force on this, then it will also will apply force on this, and both force will be will be equal. A object is taking action, so of course other object will tell a reaction. Clear? So this ball, this apple is applying force on this to attract this. So that's why reaction will be shown. Now we know that mass of earth is too much. 6 multiple 10 raised to power 24 kg. It is not a small number. This is a more, because earth, we are talking about earth, mass of earth. Can you imagine? Yeah, you can imagine. Now next, so what would be mass of apple? Of course, mass of apple would be very less as compared to mass of the earth. Very less. You can see here 0.1 kg. 0.1 kg. It is in gram. Yeah, remember, masses of the objects will matter. Will matter. We can directly tell by saying that yes, mass of this object is big, more as compared to this object. Mass of this object is less as compared to this object. You can directly tell. You can compare in order to tell the mass of the objects. Now let's see what is the connection of a mass of the object with this force. Now let's see. Here what is happening? This much mass, to lift you will have to apply more force. But for a object which mass has less, you will apply less force. You will apply what? Less force to lift less mass. So what is the connection of a mass of the object with the force? Connection is that if a mass of the object is more, then somebody will apply more force. If a mass of the object is less, then somebody will apply less force. This is what is connection. Mass is more, then force will be more. But mass is less, then force should be less. We have understood. Now here we know that F is equal to, from the chapter of force, we know that F is equal to ma. F is equal to m, where F is a force, m is a mass, a is a acceleration. So here we are saying this is about one object. This is about one object. We are saying that with this much Newton and mass of the object is this much, when we will apply this much force, then it will accelerate this much with this much mass. This is what is meaning of this F is equal to m. What are you understanding by this? You are understanding that when we will apply this much newtons, this much force, and mass is less or more, when we will apply more force and but mass is less, then it will accelerate more. But what if mass of the object is normal and we are applying very less force, then of course this object will accelerate less. Now mass is inversely proportional to acceleration. Yeah, inversely proportional. if mass will be more, and force is a certain, okay. In that case, with example, let's try to understand. If a mass is more, then acceleration, force is a fixed, okay, force is a fixed, and now mass is increasing, so acceleration will be decreasing, because force is a fixed. What if mass is a fixed but force is increasing? Then in that case, acceleration will increase. So here this was about the meaning of this is this: inversely opposite. When mass will decrease, then acceleration will increase. This is meaning of this. So mass is inversely proportional to acceleration. It is saying that when mass will decrease, then acceleration will increase. When acceleration will decrease, then when mass will decrease, and mass will increase, then acceleration will decrease. Inversely, just opposite. When inversely what will come, then you understand that yes, opposite. Work is happening opposite. Now in this case, we know that mass of the earth is this much. Okay. I have lucky, I have to carry apple. Yeah. Because of the mass of this this apple is less. In this case, earth falling towards apple. Yeah, it falls towards the earth falling towards apple. What? This is not possible. Earth cannot fall on the apple. That is not possible. In this figure, this is a force. Okay, we have a solar planet. Gravitational force is where this. Okay, this is planet. This is a satellite. These are planets, and it is a what? Sun. Gravitational force is here at the center. Okay, at the center, no problem. This force of attraction between every two objects in this universe is called the gravitational force. We are crystal clear. That two or more objects will attract to each other, not repel to each other. This is what is gravitational force. And you know that gravitational force is the weakest force. Weakest. When two objects will be attracted to each other, then gravitational force will be very weak, which is the nature. It is happening naturally. Now, what is happening over here? These waters are falling on the earth. This is also, it is happening also because of. Question is that why is this water falling on the earth? Reason is that gravitational force, because it is attracting this earth. During rainfall, why does rain droplets fall towards the earth? Not opposite. Why not opposite? Because it is all this are attracting towards the earth. That's why. It is applying downward force. Okay, it is applying downward force. Gravitational force of earth. What is the centripetal force? What is the centripetal force? Let's see. After this, we will understand about what is the universal law of gravitation. So here I got it. Gravitational force is the reason. This apple fell on my head. What is the reason? We want to know. Attraction. Yeah, this is attraction. Attraction is just what? In this context, attraction is just a gravitational force. Yeah. Okay. Yeah. It is attracting this object. and this earth is attracting this moon. We know. Same here, both are here. What is happening? This is the center, this is center, and both are rotating, and it is making a circle. So with the help of this, these two are able to move circularly, isn't it? So it's all about the center. This is known as the centripetal. With the help of this force, these two are able to make a circle, and it is moving here. When we rotate this, when we move this like that, then what happens? It rotates in circular way. It starts rotating in circular way. So this position of this will be at a circumference of the circle. It happens like that because of this is depend on this center. When motion of this will decrease, then it will not start rotating. Here you can see what is happening. This is attracting this center. This is what is happening. This is attracting this center. It is applying downward force. Now here, change in velocity. When there will be change in velocity, then there will be something change. What? Acceleration. Change in velocity, then acceleration. Change in velocity is acceleration. Meaning of acceleration is what? Change in velocity. Then acceleration is what? Force. This is force, and here is what? Acceleration. This is acceleration. And here we will realize a change in velocity. Such body is moving in a circular path. Yeah, this body is moving on a circular path. Their direction of velocity at every point, direction at every point, this change in velocity causes acceleration. When there will be change, then it will be changed because of acceleration. There happened changes in velocity. That's why there is a change in this with this body. The change in velocity causes acceleration, which results in a force. Yeah. This is center, as we know, and this is force. It is attracting towards this, and this is attracting this towards this. This is what is happening. And here central force is like that, a straight arrow. Central force, centripetal force, which means from center. Force is coming from center. Here, this is able to move circularly because of force is coming from here, center, and this is what is known as centripetal. And it will be continue with this, but here there can be changes in velocity, there can be changes in acceleration. It will depend on this, acceleration will depend on this object, this is center. Same here. So here this earth is able to move because of this. Here you can. Same here, both are able to move circularly because of this center. Center will change the velocity. Center will be able to change in velocity. Center. Now next, a force that acts on a body, moving in a circular path and is directed towards the center around which the body is moving is called the centripetal. Because of a centripetal force, moon keeps revolving around the earth without falling towards. Yes, without falling towards. It keeps falling around the earth because of the centripetal force. Here, all these are depends on this, and it is at center. All these are depends on this. This is the answer. Why does the planets keep revolving around the sun without falling towards? Because of reason is that centripetal. The planets keep revolving around the sun without falling towards it. It is because of a centripetal. Yeah, we know. Universal law of gravitational. Universal law of gravitation. F is equal to what? From the chapter force we know that F is equal to m. But in this context, what would be F is equal to? Just little different. Universal law of gravitational. In this case, universal law of gravitational states that every object in this universe. Definition of universal law of gravitational, it states that every object in the universe attracts every object with force. Yeah, there is an attraction between two objects, which means there is a force, and that force we are going to calculate with the help of a formula. And how will formula come? We will see. Proportional to the product of their mass and inversely proportional to the square of the distance between them. Let's try to understand. This is mass of this object. This is mass of this object. It is a less, that's why this is a small. This is a more, that's why this is a big. Now this would be from here, from center. We will start from center of this mass and from center of this mass. So this from here to till here, this is a distance, which is a r. Now, so here IF is inversely proportional to a both of mass of both objects. So m multiple m. Wow. Then 2mm, 2f. Here we have mass. Here f inversely proportional to 1 upon r square. Yes. And r square is increasing, then force will decrease. Yes, I got. Here what is happening here? Look at it. When masses of both objects will increase, and this will increase, then force will increase. This is what is meaning of over here. When masses of both objects will increase, then force will also increase. Yeah, you can observe. That's why, that is the reason behind revolving all the planets around the sun. We know that mass of the planets are more, and this is the reason they revolves circularly. And here it is saying what? When masses will increase, then force will increase. And here 2mm, 2f, 2f. Here, when distance between them objects will decrease, then f will decrease. When r will decrease, then when distance will increase, then of course, here what is the meaning of increasing distance? We are saying that both objects are going far away to each other. So here of course attraction force will be less. Attraction force will be less after covering more distance. But on the other side, when both will come near to each other, then force will increase. Force will increase. Then impact will be more. This is what is meaning of this mention. Remember, when masses will increase, but distance is normal, and masses are increasing. In that case, force will increase. But what if masses is fixed? Okay, masses of the two objects is fixed, but distance is more. It is keep increasing. In that case, what will happen? Force will decrease. Okay, automatically. 2r now. So we will multiply this by this. Here we have mass, and this distance is what? Acceleration. Yeah, we can consider it as acceleration. Here it is giving a distance, direction. We are saying F is equal to m, which is the mass of the body, and then upon 1 upon r. We are taking distance, acceleration. So after simplifying this is coming. J is a gravitational constant, F is mass of the object, this is the small mass of the object. It is a distance we know, and this is what? A square. Why a square? From here to till here, and double of this, again this is coming from here to till here. If you take a 2, then we are saying that from here to till here this is a 2, and from here to here this will be also 2. So this is R2 and this is R2, 4. If you will take 3, so from here to till here, half of this would be 3, and half of this 3 is a 9. It becomes 9. What is happening here? I know even I am getting confused, but later I will explain it in details about R square. Okay, in this context. In this formula, you can say G is coming. Okay, G is coming, so it will be constant, universal gravitational constant. Okay, this will be, and I think so. It k is equal to 1. I think so. K is equal to. But what about the value of Z? Let's say. So yes, G, then m multiple m upon r square. Here we wrote this 2 times because both are different. That's why both are not same. You cannot ignore one thing. Okay, one of them thing. M is representing mass of the objects, and it is measured in kg, as you know. And force, which is unit, is what? Newton. Okay. Now distance, for distance, meter, we know meter. So we are going to find what units of this. So what would be here? This is what? Meter. So meter square, then upon, no, here meter square. Here kg multiple kg square. So it would be what? Kg square into meter raised to power minus 2. Yeah. So unit of Z would be, unit of Z should be what? Unit of Z is what? This much. Newton meter square, kg square, meter square, kg raised to power minus 2. And here this Newton is what? This gravitational force. It is a Newton, because the gravitation is a force. That's why we know that force, SI unit of a force is a Newton. So here SI unit of this would be what? This much. SI unit of this, not SI unit, units of this is this much. N is a force, N is a for force, meter square is a for distance, kg square is a for masses. Value of a z here, for this it is talking about this z, so value of this would be this much, clear, this much. It is a very less, you remember this is very weakest. After simplifying it, you will get very less number, even 0.00000 like that. It is very weakest, believe me. Clear. Next we have, if the distance between two objects decreases 3 times, what happening? Distance decreases 3 times. What change will occur in the value of a gravitational force? Then gravitation, hold on, force will increase, because distances are decreasing, that's so in that case force increases 9 times. Okay, because distances are decreasing, that's why. Now next, we have questions. Okay, we have seen this. Now what is the magnitude of a gravitational force? What is the magnitude of a gravitational force between the earth and a 1 kg object on its surface? Hold on, what is the magnitude of a gravitational force between the earth and a 1 kg object on its force? So mass of the earth, we know that it is fixed this much, and radius of the earth is this much radius. We are not saying distance of the earth, radius, it is talking about radius. Then just we have given this, and just to calculate what is it saying? Magnitude of a gravitational force. So mass of earth is what? This m, and here 6 multiple, this is what it is, mass of the earth. Yeah, we know radius of the earth is, hold on. So this is it is this much is a mass of this. Now radius, it is talking about it is starting from the center till the circumference of the earth. This from here to till here, this is a radius. Now here, mass of the object is what? M. This is for small. Okay, now mass is 1 kg. This is not about this. Gravitational force would be how much? If we have two objects, mass of the one object is 1 kg and mass of the earth is 6.4 multiple 10, 6 multiple 10 raised to power 24, and radius of the earth is this much. Then force will be equal to, gravitational force will be equal to, we know that this is formula. And how did it come? We have already seen. Now we are going to use this formula so that we can find, we use this formula to calculate gravitational force, to calculate masses of the object, to calculate distance, to calculate all this. We use this formula. So where J is this, we know that J is a fixed this much gravitational force. This is value of this G, and distance, I think it is not clearly given. So whatever is given is written over here. Yeah, 6 multiple 10 raised to power 24. Okay. What is happening over here? We know that J is coming first, then M, then R is of this M, then M in this, on its surface. A object is on earth surface. So we substituted this and this multiple this, so this, and this is what? Distance. This is what is the distance. Because both another object is at the surface of the earth. So this we will get this radius as our distance. Now here this is the value of a z, and this is value of a mass of the earth, and this is value of a first second object. This is value of a mass of the second object, which is the on surface of the earth. We have substituted. Now our work is to simplify this. After simplifying this, you will get force in exact number. So this is your work. Okay, this is your work. Now next, recall test. We have some questions on this. The force due to which objects are forced towards the earth is called gravitational. It is not rotating, it is a falling towards the earth. So that's why this is gravitation. If the masses of the two objects will increase, then what will happen? Then gravitational force between them will also increase, because masses are increasing, and here distance is fixed. That's why both will give more force. So answer is not mentioned. It is not. Third question is, if the distance between two objects, distance between two objects r square, the gravitational force between them, hold on, distance is increasing, mass is fixed. If a mass is fixed and distance is increasing, then of course force will be decreasing, because of distance is increasing. Now fourth question is that centripetal force do not act towards the center of the circle path. Do not act towards the center of the circle path. I think it should be wrong. Because centripetal force is what? A force which is coming from center, and this center gives force to move the other object in the way of rotating. So fourth, false. Fifth is universal gravitational constant is denoted by G. Yeah. Next, the force due to which object falls towards the earth. The earth is called, right. Next, false, yes. All the answers are correct finally. So next, concept test. This is a concept test. In this case, law of gravitational gives law of gravitational gives the gravitational force between two masses of the objects, between earth and point mass only. No, earth and sun only. Any two bodies having some masses, the earth and apple. Yeah, this is the correct answer. C. This law of gravitational is for all objects, not only for earth, not only for apple. It is for all objects. We can observe gravitational force, law of gravitational, with any objects. So C is the correct answer. Now solution. We have studied in universal law of gravitation that every object in this universe attracts every other object. So here everyone is coming. But in this question, here only. That's why it is becoming wrong. So this is done. This is your solution. Okay, behind your answer. Now concept. If distance between two objects increase 4 times, then gravitational force becomes what? Here, hold on. Distance is increasing, which is more times. In that case, force will decrease. Force will decrease how much? 1 upon 14. 1 upon 14, I think so. 1 upon 14.